Hello, welcome to home learning for August 25th if you're the A through L group and August 26th if you are the M through Z group. Today we're going to be talking about transversals. Transversals are lines that cross at least two other lines in the same place. Since this is singular, we're going to put a transversal is a line that crosses at least two other lines, put that in parentheses, in the same plane. I think I said place a minute ago, but that's okay. So those two other lines, they could be parallel or they might not. Most often in geometry, we talk about the lines that are parallel because they tend to have certain qualities that non-parallel lines would not have. For example, corresponding angles, if the lines are parallel, should be congruent. So we're going to put the symbol for congruent and then put if lines are parallel. So corresponding angles are angles that I describe as being in the same address but in a different neighborhood. Same address, different neighborhood. So what that means is, for example, angle 6 and angle 2, their little neighborhoods are the intersections, right? This little intersection, this little intersection. And within those two intersections, angle 2 is on the top, angle 6 is on the top. That's how they're in the same address but in a different neighborhood. Another way that you might think about this is that the angles could slide on top of each other if you were able to slide them down the transversal. So same address, different neighborhood, or would slide into each other's spot. And we'll just understand that that means if you could do such a thing. So if the lines are parallel, we could take angle 6 and we could slide it down, and if those lines were parallel, it would line up just perfectly with angle 2. Or angle 2 could slide up in a line with 6. So angle 2 and angle 6 are one pair of corresponding angles, but you also have others. Just like 2 lines up with 6, angles 1 and 5 are corresponding. Angles 4 and 8 are corresponding, and angles 3 and 7 are also corresponding. After the corresponding angles, we have the alternate interior angles. Alternate interior angles are also going to be congruent if the lines are parallel. Alternate means that they're on opposite sides of the transversal. And you'll see that down here with alternate exterior as well. So I've kind of let that description bleed over into the next category, into the next little section. But it means the same thing. Alternate just means opposite sides of the transversal. And then you have interior, which just like the interior of your house means inside. This means that they are inside or between the parallel lines. I'm going to put parallel symbol over here, right? I'm going to start saying parallel like this instead of writing it out, just for ease. You can do the same thing. One example of alternate interior angles would be angle 5 and angle 3. So angle 5 and angle 3 are alternate because of this transversal, which runs through the entire diagram. Angle 5 is on one side and angle 3 is on the other. They're as far away from each other as they could possibly be. They are the alternate angles. And they are between these lines that we would like to be parallel, but on this sheet are not. And so they are, by definition, alternate and interior angles. So as long as you know what alternate means and you know what interior means, those should be pretty easy to identify. Alternate exterior angles are pretty much the same idea, but instead of being in between or inside, exterior means outside the parallel lines. So, if our angles in here were interior, then 1 and 4 and 6 and 7 would be the exterior angles. The ones that are alternate exterior would be like 1 and 7, as far apart as you could get, or 4 and 6. Those are also as far apart as you could get, so they are alternates. I'm just going to use 1 and 7 to give ourselves one example. Just like that. So alternate means opposite sides of the transversal, exterior, outside the lines. Then down here we have same side interior and same side exterior. Same side interior angles are going to be supplementary. And if you remember from class, you should remember that that means they sum or add up to 180 degrees if the lines are parallel. Another word that you might see, or another name that you might see, sorry, I should turn this. Another name that you might see for same side interior is consecutive interior angles. They mean the exact same thing. Consecutive just means one after the other. Same side means same side of the transversal. But if you look, we're talking about interior only. So that is 2 and 5 or 3 and 8. So they are one right after the other, and they are on the same side of the transversal, and they are interior to these two lines that we want to be parallel. So, our example then, the one that I chose was 2 and 5. And just like on all of these other kinds of angles, there are other examples, but we had to start with one. Our last kind of angles that are particular to transversals are same side exterior angles. Well, we've already talked about same side, and we've already talked about exterior over here. So this one should pretty well be self-explanatory. They are on the same side of the transversal, so for example, all of these, but they are also exterior, which means they are outside the lines, so we've got 4 and 7. Or if you go the other way, 1 and 6. So we're going to use 4 and 7. We're going to kind of color code those. Even though 4 is not filled in, 7 is, and I want them to have the same markings. So that's why I'm doing it this way. Just like same side interior, same side exterior should be supplementary, or the two angles add up to 180 if the lines are parallel. So that is the list of items or angles that exist when you have transversals. Now, again, we talk mostly about them with parallel lines because when you have parallel lines, you have these congruent and supplementary relationships. If the lines are like this and they are not parallel, then you do not have these congruent and supplementary relationships. With that said, we also still have vertical angles. We also can still have linear pairs. We talked about those in class on Monday or Tuesday, whichever day you were here. Those are still things just because we have other names to add to it doesn't mean that these go away. So for example, 7 and 5, they're still vertical angles. They are vertex to vertex formed by exactly 2 straight lines. 6 and 7 are still a linear pair. They still rest on the same line and share a ray in between them. So those things don't go away. They're just kind of over here in the background as we're learning about the new names for these new kinds of angles. On the back of the sheet, you have some different blanks to fill in just to kind of review what goes with what. Okay. So if M and N are parallel, here's M, here's N. If they are parallel, then we have these supplementary and congruent relationships. So we're looking for a pair of alternate interior angles. Well, that could be 3 and 6. It could also be 4 and 5. So we're going to put angle 3 and angle 6. 4 and 5 would have been equally as accurate. Angle 2 is congruent to angle 7, and angle 1 is congruent to angle 8. And then you're supposed to be naming those angles. Well, 1 and 8 are on the outside, so that's an exterior something. And then they're also on opposite sides of the transversal. So these are alternate exterior angles. Then we have corresponding angles, and you're going to have 2 pairs of those. You can pick any 2 pairs that you like as long as they are in fact corresponding. And I think you kind of get the idea. You're just going to go through here and fill in with accurate sets of angles and accurate names. We're going to skip the converse. That's going to be a topic for a later day. But I do want us to go ahead and flip to the very back page of the packet. On this packet, you're going to start by just naming the angle relationships with parallel lines. So this is why we know we can say that angles are congruent or supplementary, is because we're told that they are parallel. So for 1 through 10, you're just very simply naming the relationship. Please notice on 10, you have to identify which 2 lines and where the transversal is, and then you just kind of ignore the other 2 lines to figure out the name for that relationship. For 11 through 18, and continuing on to the back, you're supposed to be telling the angle measure for each of these. Here is the little memory trick that I teach my students every year to get them started on this, or I guess to jog their memory. Every obtuse angle is the same measurement as every other obtuse angle, as long as these lines are parallel. Every acute is the same as every other acute, as long as these lines are parallel. So assuming that the lines are parallel, I have them go through and I just pick 2 shapes. I always do circles and stars. So all of my obtuse, I put circles because it kind of looks like an O. And then stars go in all of my acute. You can do whichever shapes suit you. Just make sure that all of your obtuse are marked with 1 shape. All of your acute are marked with another. Any circle matches any other circle. Any star matches any other star. That means that those measurements are equal. And then any pair of circles plus stars should add up to 180 degrees. So once you've got this drawn, it's going to be pretty easy to go through here and kind of just identify very quickly, are these going to be both circles or both stars? Or is it going to be a pair of circles and stars? Also on the back, same thing, but instead of having just numbers, you have some expressions in there. So for example, this would have been one of my circles. This would have been one of my circles. So I would have set up x plus 139 equals 132 because they were both the same shape, so they have equal measurements. So also down here, it says find the measure of the angle indicated in bold. Just because the bold ones are a little bit hard to see, I'm going to circle those for you. So that, in a nutshell, should be enough to get you started with parallel lines and transversals. Look forward to seeing you guys soon and talking some more about this in class.